The change in gravitational potential energy when a body of mass m is raised to a height nr above the surface of Earth is. So our aim is to find out what about the value of change in potential energy. So we can just consider that initially the object was on the surface of Earth. So from the surface of Earth, consider that we are having an object of mass m is raised to a height which is equal to nothing but n times the radius of Earth. And the radius of Earth we can take it as nothing but r. And Rm is to find out what about the value of its increase in potential energy. So this we can take it as the final point, and this we can take it as the initial point. So the increase in potential energy we can take it as it is the final potential energy minus initial potential energy. So we can write change in potential energy is equal to final potential energy can be written as nothing but gmm minus of gmm divided by, we need to take the distance from center to this point, to the final point. So that is equal to nr plus r minus, we can write the equation for its initial potential energy, which is potential energy on the surface, which is not equal to 0. We need to write the actual gravitational potential energy, which is gmm divided by r. Now we can find out what about the value of its change in potential energy over here. So this is going to be, we can take this gmm and we can take this r is common over here. So this is going to be r into n plus 1 minus of gmm divided by r into n plus 1 minus, we can take this minus minus, it becomes equal to plus gmm divided by r. Now we can write this as gmm divided by r into, we can take this one over here, that is minus of n plus 1 plus 1 over here. So this can be written as nothing but gmm divided by r into, if you are taking this as n plus 1 as LCM, we can take it as minus 1 into n plus 1 divided by n plus 1. So this plus 1 and minus 1 get cancelled. We'll get it as it is gmm into n divided by r into n plus 1. Now we can observe that in options they are given in terms of g, acceleration due to gravity on the surface. To write it in terms of acceleration due to gravity, what we'll do is we'll multiply it with r and divided by r, so that while combining these two r and r, we can write this is equal to r square. So the equation becomes gmm into n into r divided by r square into n plus 1. Now this term gm by r square is representing acceleration due to gravity on the surface. So we can write this as g into m into n into r divided by n plus 1. This will be the value of its change in gravitational potential energy.